Hi everyone, today we are working on 4.2, Solving Systems by Graphing, Day 1. This is due on Tuesday. So today we're going to talk about how to solve a system of linear equations by graphing. And the strategy there is to graph both equations and find the intersection. Because in class we talked about how the solution to a system is the point where the two lines cross or are equal. So example 1, on the set of axes below, solve the following system of equations graphically. State the coordinates of the solution, and the coordinates of the solution will be x comma y. So this example here, we got to change this, okay? So I really hope everyone's listening carefully. We are changing this problem because we did a similar one already in class. We're changing this first equation to x plus y equals 3. And we're changing the second equation to 4x minus y equals 2. Okay, so step 1 is to number the equations. So we have two equations in our system. This is equation 1, this is equation 2. Step 2. Make sure both equations are in y equals mx plus b. Okay, so it has to be in slope-intercept form, meaning that the y has to be isolated on one side of the equation. And if we look at both of our equations, the y is not isolated. We need to do some work. So equation 1 is x plus y equals 3. To get y by itself, I'm going to do my onion method. I want to get y by itself, and right now x is being added to it. So in order to get rid of the x, I use the inverse operation, subtraction. Subtract x to the other side. And then I'm left with the x's canceling out. Y equals, and this was a positive y, so I'm writing this as just a y, is equal to 3 minus x. That's my equation in slope-intercept form. Y is isolated, so this one's good. Equation 2 is 4x minus y equals 2. I need to isolate my y, so I'm going to circle my y. I have a minus sign next to it. And then I have the 4x. So in this one, the first step is to remove the 4x. That's in my outer layer. So I subtract 4x on both sides. Then I'm left with these canceling. Now I have negative y, bring down that minus sign, is equal to 2 minus 4x. Is my y isolated? No. Because in slope-intercept form, y is positive and it is isolated, so it has to be positive. So why is there a negative there? That is just saying that there's an invisible negative 1 next to y. So the inverse operation that I need, and I'm going to draw my onions again. I'm circling the y because I want to get y by itself, but there's a negative 1 around it. I need to divide by negative 1 on both sides, on every single term. And then I'm left with y equals 2 divided by negative 1 is negative 2. Negative 4x divided by negative 1. I can divide these coefficients. Negative 4 divided by negative 1 is positive 4. And then the x. Great. So now is my equation written in slope-intercept form? Yes. There's a few things that I want us to recognize here, which is that these are both linear equations, which is what we're graphing. We're graphing a system of linear equations. So every linear equation has a slope and it has a y-intercept. So let's look at our first equation. When I isolated the y, my slope is, well, it's the number next to x, which in this case there's a minus sign. So the slope is negative, and an imaginary 1 is there, invisible 1, negative 1. And my y-intercept is the number by itself, which is 3. So this is going to help me do step 3, which is to fill out the table. If I know my y-intercept is 3, That means when x is 0, y is 3. Okay? And if I know my slope is -1, well, all of the x's, that means my y's are going to change by going down 1 each time. And I'm going to keep my x's going up by 1. Just keep it the same. 0, 1, 2, 3, 4, 5. And I'm not going to fill out the rest of this table. This is enough points. It's going to go up a standard 1 each time in the x's. And then in the y's, 3 minus 1 is 2, minus 1 is 1, minus 1 again is 0, minus 1 again, -1, minus 1 again is -2. This comes from our slope. Okay, that's why we're subtracting 1 each time. So these are the coordinates we're going to graph on our graph for equation 1. Equation 2, let's do the same thing. I'm sorry there's not enough space, but we'll write it here. So my slope here is the coefficient next to the x, which in this case is 4. And my y-intercept is a number by itself, -2. So in my table, I always start with my y-intercept. So if my y-intercept is -2, my y value is -2, and x has to be 0, wherever there's a y-intercept. And then I'm going to make the x's go down a regular amount, 0, 1, 2, 3, 4, 5, going up by ones. And then on my y's, it's going to go up by the slope. In this case, it's a +4. So my slope, +4, means that the y's are adding by 4 each time. So -2 plus 4 is +2, plus 4 is 6, plus 4 is 10, plus 4 is 14. Again, this comes from our slope being 4. Now that we have our table, step 4 is to graph. Graph equation 1 and make sure you're labeling it. Because there are two equations in the same graph, we have to make sure we're labeling. So I'm going to plot my points for equation 1 in purple. So we have 0, 3, 1, 2, 2, 1, 3, 0, 4, -1, and 5, -2. And I'm going to connect that with a straight line. If you have a ruler or a straight edge, make sure you're using that. Okay, so I'm going to label this equation, equation 1. And step 5 is just to repeat these steps. I already filled out the table, so oops. I forgot to fill out this one. 5, 18, because we're adding by 4. Now I'm going to graph my equation 2, and I'm going to graph that one in blue. Okay, so 0, -2, 1, 2, 2, 6, 3, 10. The rest of the points don't fit, and that's okay. Just connect it with a straight edge, draw an arrow because this line continues forever. And this is my graph for equation 2. Make sure you're labeling it. And very nice, because we see our solution, which is where these lines cross. So step 6 is to write the solution and write your coordinate. So it's not write your solution, sorry. You have to find your solution. In this case, we can see it. And we have to write it as a coordinate. It has to be an x, y coordinate. Okay? And we might want to first write what x equals, write what y equals, and then we can make our coordinate. So our answer here is, well, it's where it crosses, and I'm going to circle that in red. Right here is our solution. And our solution here is the coordinate 1, 2. So I'm going to label it. My solution is 1, 2. That's the coordinate. The solution to the system is 1, 2. And underneath that, I'm just going to make sure it's clear that x was equal to 1 and y was equal to 2. And that's how we got this coordinate here. If you have any questions, please make sure to write them down below. See you guys tomorrow.